My name is Zahirauddin Maheshwara Surono, and my ZID is z5610276. And in this video, I'm going to try to understand our solar system through exploring the orbits of astronomical objects, such as the orbits of planets around the sun or the orbits of the moons around the planets. First, we must know the three Kepler laws. So the first one is basically saying that the path of the orbit of the planets are ellipses and not perfect circle. The second law states that in a given time interval, if you take the line from a planet to the sun at any point, it's going to sweep the same area. How does it work? So this is explained by the fact that the speed that planets orbit the sun is actually not constant. It's ever changing based on the distance that the planet is from the sun. So at the perihelion, or otherwise known as the point closest to the sun, it's actually where the planet moves the fastest. On the other hand, in the aphelion, the point farthest from the sun, the planet moves the slowest. The third law actually describes a mathematical relationship. This describes that the square of the orbital period is directly proportional to the cube of the semi-major axis. So as the moon orbits the planet actually moves and wobbles and vibrates. That's because the moon's gravity still affects the planet. But because the planet is heavier in mass compared to the moon, the center of mass is still within the planet, so the planet doesn't actually orbit around the moon, but it simply just vibrates around the center of mass. So qualitatively, in question 1, the center of mass is near the center of the star. In question 4, however, it's still deep inside the star because the change in the planet's mass is still not big enough. However, on question 7, it depends on how you change the mass. The center of mass shifts towards the planet if the sun mass is decreased, but shifts deeper into the center of the star if the star's mass is the one being increased. The planet's mass isn't too much larger than the moon, so the center of mass is more shared between them. The star, however, is so much heavier in mass that the center of mass is still inside the star, so it doesn't wobble or move as much as the planet orbits it. The distance between the sun and the earth is 1 astronomical unit, so the length of the grid is half, or 0.5 astronomical units. So these are the orbital distances I chose, and these are the periods. So these values are actually very close to the theoretical ones calculated by Kepler's third law. Discrepancies are caused by human error for not making it like a complete perfect circle in the simulation, as well as the count for the period being rounded up to whole numbers in the simulation. Mercury is the planet with the fastest linear speed. However, on the other hand, Neptune is the planet with the lowest linear speed. Mercury is fastest because it's closest to the sun and therefore needs higher linear speed to make sure it stays in orbit and resists the pull of the sun's gravity. Neptune, on the other hand, is farther from the sun, and if it is too fast, it might stray away from orbit too easily, as the sun's gravity isn't as strong as it is to Mercury. This can be further explained using this formula. This equation basically says that the smaller the radius is, the higher the linear speed. I learned how well the Kepler's laws explain how the planets orbit the sun. I learned that the sun's mass, the linear speed of a planet, the distance the planet is from the sun, can all affect the path of orbit and the period of it. I learned that all these things are why the solar system is how it is today.